problem, right? Okay, started. I forgot to switch on the camera. I switched on before. When did I call? Like when we made the call in the group, it cancelled the recording. Yeah. Yes. How did you solve? Can you tell? What's the answer? 3.4 times 10 to the power. Yeah, okay, very good, perfect. What is the direction of the electric field? Very good, 15 degree, right? Okay, 15 degree north of east. Yes, very good. Ahmed, you were telling something. Yeah, same answer, okay? Like 40,000 is 4.0 times 10 to the power 4, right? 10 to the power 5, I think, right? 4, okay. Yeah, okay. Yeah, 4,000 is 3, 40,000 4. Yes, correct. Then what about Yara and Usoon? Do you understand perfectly? Okay, very good. So we will continue, okay? So first question that we discussed didn't mention in the Heikel, okay? From 24 to all the questions mentioned in the Heikel. So question number 24. You write it, Islam. Are you writing or just putting in the calculator? Okay, you did it before. Okay. Okay, so this time Usoon can explain the question. Explain the answer after you finish. Kusun, did you finish? Okay, fine. Yara finished, right? So we will wait for Usoon also to finish. Ahmed, I think, must have finished. Ahmed done, right? Yes. A positive test charge of 5 times 10 to the power minus 6 is in an electric field that exerts a force, which means positive. Okay, if they didn't say negative, it is positive always. Okay, so can you explain? Very good, right? Okay, yeah, Newton per coulomb. Okay, what is the unit of electric field? Newton per coulomb. Okay, force divided by charge, right? Force by charge. So Newton per coulomb. Okay, then we will go to question number 25. Wait, I will give you 2 minutes, okay, for all of you to finish. Then this question Yara will solve. Test charge. The charge you are using to test the electric field. Yes. Yeah, this will be big answer because the charge is very small, right?
A candy.
Yeah, a negative charge of, yes, when you say the magnitude, you don't have to use the negative sign, okay? Yes, yes. Okay, put the absolute value. So yes, Yara, can you explain the question? So yes, yes. So very good, perfect. Okay. So the magnitude of the force is 3 times 10 to the power 6, right? Okay, very good. The next question, a positive charge of this one located in a field is given, okay, towards the south. What is the force acting on the charge? So direction is given, right? So when we say when we calculate the force, we will tell the magnitude and direction of the force, okay? So Ahmed is remaining, right? Okay, so first I will give you students 2 minutes to answer this question. After that, Ahmed will explain this one. 26 now. Usun, everything clear? No need to explain on the board, right? Okay, okay. Yara, which question are you in? Yes. Yeah, that is electric field. If it is given in Newton per coulomb, then electric field. Yanis? What? Okay, Ahmed finished. 26. Okay, can you explain? minus 6, right? Okay, so answer is 8.1 times 10 to the power minus 6. Yeah, direction of the force will be south. Okay, so the answer will be like this. The force is 8.10 times 10 to the power minus 6 Newton to south. Yara, finished 26. What's your answer? Yeah, Newton, right? Negative 6 Newton to the south. Okay, you should write the unit also always. Usun, same answer. You wrote the unit and direction, right? Okay. The next question, 27. You have to complete that table. In the first question, first row you need to calculate electric field. Second row you need to calculate force. Third row you need to calculate charge. Okay, so do it. Okay, then after 2 minutes Islam will answer. Okay, Islam. After you complete the table, if you have already completed, you can go to question number 28. Okay, so Islam will explain, right? Okay, start. Very good. Yes. Very good. Very good. Okay. Yes, Ahmad, Yara, Husoon, did you all get the same answer? Yes. Okay. 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 So in the first one, you want to calculate electric field intensity, right? Yeah. Yes. Yes. Somebody was asking the first one. Who was asking the first one? Okay. So last one, right? The equation we have is force is equal to, sorry, electric field, right? Yeah. Electric field is equal to force divided by charge. This is the equation, right? So if you want to calculate a charge, so the charge will go to this side, electric field will go to this side. Okay. So charge is equal to force divided by electric field. Okay. Yes. Any question, Yara? Did you complete the table? Okay, how much? Can you tell the answer? So we will write here. 3 times 10 to the power 5 Newton per coulomb. What is the second one? 0.66 Newton. Okay, third one? Okay, check. Are you all getting the same answer? Yeah, that is correct, right? You can keep your calculator in the standard form. Okay. Are you using the calculator like this? Ahmed? Okay. So you can you can change it into scientific form, the calculator. Okay, but your answer is correct. Okay, your answer is correct. For example, in the exam you got like this 300, right? 300,000 Newton per coulomb, right? So how will you change that into standard form? For example, in the choices they have given all the answers in standard form. So you can like from here 1, 2, 3, 4, 5, right? So the you are jumping 5 times to reach a 3. So 3.0 times. How many times jumping? 5 times. Okay. Count zeros, but if the number is like this, for example 302189, then yeah, after the first one, right? Yeah, very good. Okay, after the first one, 1 2 3 4 5, right? Okay, very good. So 3.02, right, into 10 to the power 5. Yeah, that's good. Count the places after the first one. Very good. Okay, students, can I erase? Yeah. Question number 28. A negative test charge is placed in an electric field as shown in the figure. It experiences a force as shown. What is the magnitude of the electric field at that field at the location of the charge? You know that, right? How to calculate it? Force and test charge is given. Yeah, normally you calculate. That is why I said, right? Listen, in the textbook, source charge is given like Q. Okay, test charge it is given like we call it q prime or q dash. Okay, I thought when I write like you may feel confused, you will ask what is this one. So what I did is, in the worksheet source charge I put capital Q. Okay, test charge, instead of q dash we wrote a small q. You can use either one. Okay, Usun, do you understand? Comma represent the test charge. What's the answer? Force by charge, right? 0.08. What I am getting? I am getting, yeah, 1.6 times 10 to the power 5. Listen, what's, yeah, how to solve this question, right? So in this question, same as before. Okay, what is given? The difference is only here image is given, the diagram is given, force and test charge is given. How much is the force? 0.08 Newton or 0.080 Newton. And how much is the test charge? Test charge is negative. Okay, minus 5.0 times 10 minus 6 coulomb. We need to calculate the electric field strength. If we have force and test charge, we have our equation to calculate electric field strength. Force divided by test charge. Force is how much? Force is 0.08 Newton. And the value of test charge minus 5.0. If you use or you don't use minus, no problem. Minus 6. But this minus you must use, okay? Yes. How much is the answer for electric field? 1.6 times 10 to the power 4 Newton per coulomb, right? Okay. See, direction of the force is not given, right? Yes. Yeah, so here electric field is negative, right? Correct. Electric field is negative and the force is positive, right? Okay, so yeah, force is positive means force is repulsive force, correct? If the force is positive, what is the meaning of that? It is a repulsive force, correct? And electric field is negative, which means the direction of electric field is towards the direction of the source charge. Okay, so for example, here we have a charge, right? Charge Q, this is our source charge. Here we have test charge Q. Okay, so this test charge is negative, right? Minus. Then what is the force given in the question? Force is how much? 0.080. Okay, students, see here, one of the charge is negative, force is positive. You know that if the force is positive, a positive force means repulsion, correct? Yes. So here there is a repulsive force, right? So this charge will be negative, right? Correct? Yeah. No, like charge repel, right? Like charge repel. Yeah, where is the direction given? What is the it experience a force shown. Force is towards Q, right? Yeah, direction is given, right? Okay. Force is towards Q. I didn't see that. Sorry. Force is towards. This is the direction of the force, right? Okay. Sorry. Okay. So if this is the direction of the force, then and this is a negative charge, right? This is a negative charge, and this is the direction of the force. Okay. Yeah, so it will be away from Q. Okay, electric field will be away from Q. The direction of the electric field is always opposite to the direction of the force on a negative charge. Yeah, I didn't read that. Okay, the next question, you are probing the electric field of charge of unknown magnitude and sign. You first map the field with a 1.0 times 10 to the power minus 6 coulomb test charge, then map it with a 2.0 times 10 minus 6 coulomb test charge. Would you measure the same force at the same place with the two test charge? Explain. Would you find the same field strength? Explain. Okay. Do you understand the question? Okay. See here. Right. Here we have a charge. Okay. A charge. This we will write Q. This charge is producing electric field. We will take one point here. Okay. 1 point. So here you place a 1 coulomb charge. 1 coulomb charge if you place there. This point is at a distance r. So this 1 coulomb charge will experience a force F. Okay. 1 coulomb charge is experiencing a force F. If you place 2 coulomb charge here, 2 coulomb charge, will the 2 coulomb charge will experience same force or different force? Listen, for example, here I will give you a charge, okay, a charge. For example, we will say this is, okay, so here this is a 5 coulomb charge, okay, 5 coulomb charge. So this 5 coulomb charge will produce an electric field here, right? Okay. So at a distance, for example, at a distance 2 meter away from this charge, you place 1 microcoulomb charge here, okay, 1 microcoulomb charge. So that will experience a force, right? If you keep an electric charge, any electric charge in any electric field, the electric charge will experience a force, okay. So we can say this charge is experiencing a force that I will write F, okay. Then if I place another charge, 2 microcoulomb charge, the question is, will 2 microcoulomb charge experience same force or different force? Yes, that's a good question that you will know from this equation. The force experienced by an electric charge is equal to K multiplied Q1 multiplied Q2 divided by R square, right? Okay, so we will just calculate this. No need to calculate, okay? We will understand without calculating, but still I will calculate. K is 9 into 10 to the power 9 multiplied, what is the source charge? 5, right? Our test charge 1 microcoulomb, right? So 1 into 10 minus 6 divided by distance, we will say 2 meter, okay? So 2 square. Can you say the answer? How much? Like this, right? Okay. Then 50. Okay. Then instead of this 1 coulomb charge, we will keep a 2 coulomb charge here, okay? So how much will be the force acting on the 2 coulomb charge? It will be greater, right? Okay. Very good. It will be 22,500. Correct. When you double one of the charge, the force will double, right? Okay. Perfect. Very good. Okay. So we can say, would you measure the same force? No. We will measure different force. The 2 microcoulomb charge will experience 2 times the force, right, experienced by the 1 microcoulomb charge, correct? Or I will say the 2 microcoulomb charge will experience twice the force or double the force compared to the force experienced by 1 microcoulomb charge. Okay, students? Can I? Yes. We can write the answer in different way, okay? So we will say, would you measure the same force? No. We will measure different force. We will measure different force. Okay. So I will write by Coulomb's law. By Coulomb's law. If you write by Coulomb's law or according to Coulomb's law, done the answer, okay? Your answer finished. By Coulomb's law, force is equal to K into Q1, or we will write K into Q divided by R square. Okay? By Coulomb's law, force on a charge depend on the charge. Okay, by Coulomb's law, this is the Coulomb's law, right? Force on a charge, force on a charge depend on it, right? Or depend on the size of the charge. Or just a minute, we will make it simple. Okay, by Coulomb's law, greater charge, a larger charge, what I will write? Yeah, greater charge will experience greater force. Okay, done, students? Yeah, by Coulomb's law, greater charge will experience greater force, or we can write by Coulomb's law, force is directly proportional to the test charge. Okay. The next question, would you find the same field strength? No. See, I'm erasing. Okay, this one I hope you have written. Okay. For the second question, would you find the same field strength? Yes, because field is produced not by the test charge. Field is produced not by the test charge. Field is produced by the this charge. This charge you are not changing, right? You are not changing this charge. You are changing the test charge. What is the equation for the electric field at this point? Electric field at this point is equal to K multiplied source charge divided by R square. Okay, so for example, here is our test charge, right? Here is the source charge. Okay, Ahmad? Islam, right? Islam. Okay. So Islam is telling like this, if I use this equation E equal to F divided by Q, then electric field must depend on the test charge. See Islam, this equation. What is F? F is, you know that, K into source charge into test charge divided by R square, right? Divided by this Q. So that Q we will write here. Okay? They will die. Correct? Okay. So what is remaining? Electric field is equal to K into Q divided by R square. See, is there test charge in this equation? There is no test charge. So the electric field strength is independent of the test charge. The strength of the electric field is independent of the test charge. Would you find the same field strength? Yes. Why? According to E equal to KQ by R square equation, the strength of the electric field does not depend the test charge at all. Strength of the electric field depend only on the source charge and the distance. Okay. So we will write it here. Our answer is, would you find the same field strength? Yes. We will find same field strength. We will find same field strength. After that we will write the explanation by E equal to KQ by R square. The electric field strength, or strength of the electric field, okay, electric field strength does not depend on test charge. Okay. If you want to make it more, you can write electric field depend only on the source charge and the distance. Yes. That also not correct. Okay. because the electric field is produced by this charge, right? Okay. Well, I am trying to get. Okay. Yeah. It's for example. What can I say? Yeah. For example, two students are writing exam. Okay. Okay. Islam and another student from your class, Islam. Both of you went for an exam. Okay. So your term exam, you will get the same question, right? Okay. But like both of you will score maybe different marks. Okay. That depend on the students, right? But the exam is same for all, right? If I say is the difficulty level of the exam, or if the exam, the quality of the exam, standard of the exam same for both the students, or if I say the questions of the exam same for both the students, yes, right? Okay. The for example, we can say number of questions. Okay, the number of questions same for both the students, yes. Did they get a same score? No. That depend on the two student, right? The score depend on the student, but number of question depend on the exam. I hope you understand. Yeah, E will not depend on the F. Okay, because when we rewrite the F, when we change the F, we get the unique equation. Okay, this is the main equation for electric field. So from this equation we understand that electric field depends only on what? Source charge and distance. Okay. Okay, students, we will end the meeting and tomorrow we will continue. Okay, so tomorrow we will do the remaining questions of the worksheet, and I think that tomorrow we can do we can start another question also. Okay, thank you for joining the class. See you tomorrow.